Picture this. You're in the passenger seat of a car, and the driver suddenly rips a sharp left turn. Before you even have time to brace yourself, your coffee violently launches to the right, splashing against the center console, and your shoulder slams hard against the passenger door. If you asked almost anyone on the street what invisible hand just threw you into that door, they'd give you the exact same answer: centrifugal force. But ask a physicist, and they'll tell you something entirely different. They'll tell you centrifugal force doesn't actually exist. It is a completely fake, fictitious force. Which raises a pretty massive question. If this force is entirely made up, how can it spell your coffee? More importantly, how can NASA and the US Navy use massive mechanical centrifuges to subject astronauts to crushing levels of physical stress? To solve the mystery of this fake force causing real bruises, we have to look at the exact same car turn through two completely different mathematical lenses, the inertial frame and the non-inertial frame. Let's start by hovering above the car, looking down at the road. You are standing perfectly still, watching the vehicle pass by. In physics, this stationary, objective viewpoint is called an inertial frame of reference. From this perspective, the rules of motion are remarkably straightforward. Back in 1687, Isaac Newton laid out his first law. An object in motion will travel in a perfectly straight line, forever, unless an outside force physically acts upon it. This diagram shows exactly what that means for a turning car. The vehicle wants to keep following that straightforward arrow. To make it trace a circle, a physical force must constantly yank it inward, toward the center of the curve. We call that inward pull centripetal force. In Latin, the word centripetal literally translates dissenter-seeking. But centripetal isn't a unique force of nature like electromagnetism. It's really just a job title. Different physical forces apply for the job. For our turning car, friction between the tires and the asphalt acts as the centripetal force. If you're orbiting a planet, gravity takes the job. If you're swinging a ball on a string, it's the tension in the rope. So from the outside looking in, the mystery is solved. There is absolutely no outward push. A turn is simply a continuous, violent inward pull against an object's desire to fly straight. Now, let's put you back inside the passenger seat of that turning car. Because your environment is actively accelerating and rotating beneath you, you are now sitting in what physicists call a non-inertial frame of reference. Inside this moving bubble, your brain doesn't realize the car is turning. It just feels the seats and the walls shifting around you, which creates the very convincing illusion that you are being thrown to the side. Let's look at a geometric breakdown of the car's interior. Remember Newton's first law? Your body is simply trying to obey it. You are continuing to move in a perfectly straight, forward line. You aren't hitting the door. The car door is curving inward to intercept you. But because you are trapped in that rotating box, you feel a phantom pressure shoving you against the glass. We call this apparent outward push centrifugal force, which translates to center fleeing. This is exactly why physicists label it a fictitious force. There is no physical interaction happening here. No gravity, no magnetism, no invisible hand. What you're actually feeling is your own body's inertia resisting a change in direction. Even though it's an illusion, scientists still need a way to measure it. By treating centrifugal force as if it were a real, quantifiable push, physicists can use mathematical bookkeeping to accurately design machines and predict behaviors while operating entirely inside a spinning system. The outward push is entirely a trick of perspective. It is an illusion generated strictly by your environment moving while you try to go straight. Ultimately, centripetal and centrifugal forces are not locked in some invisible tug-of-war. They are the exact same physical event, just being recorded by two different cameras. Engineers rely heavily on the centripetal perspective when they are designing systems from the outside in. If you're calculating the precise bank angle of a curved highway or laying out the track geometry for an amusement park ride, you have to ensure the structure supplies enough inward centripetal force to keep everyone safe. On the flip side, the centrifugal perspective becomes essential when you're doing work from the inside of a spinning frame. Whether you're building a laboratory centrifuge to separate blood components by density, or just programming a washing machine to extract water from your clothes, treating that outward push as a measurable force is what makes the math work. So the next time you take a sharp turn and your shoulder slams into the car window, you'll know there's no invisible hand pushing you away. It's just the fundamental laws of the universe, keeping you moving in a straight line.